Hi everyone, welcome to my YouTube channel AI Stories by Anjali. I hope you all are doing great. So in this video, we are going to see the new topic, that is how you can compare two LLMs. So till now, we have seen many applications that uses different LLM models like Word, ChatGPT. In the GPT, we have seen so many models, right? So in this video, I would like to show you a simple question and answer system with two different models and how you can compare those two models. Because in the real life scenario, whenever you're doing your task, suppose if you have experimented with different LLM models, you want to see which model that you need to select for your deployment. This will be helpful. So let us dive deep into the video. Before going that, I would like to request to the new watchers to please like, share and subscribe to my YouTube channel AI Stories by Anjali. And also please tap the bell icon for latest notifications. And those who have already subscribed to my YouTube channel, I would like to thank you all for encouraging and supporting me. So let us dive deep into the video. So firstly, in this particular video, we would like to see about these particular things. The first thing is we have to process a set of question answer pairs through two different LLMs. So LLMs means large language models and employ simple NLP tools like BERT and Cosine Similarity to score each model's result with related to the reference response. So whatever the response that we are getting, we need to evaluate those two particular models with the help of cosine similarity. So I have explained you clearly about cosine similarity in our previous videos. So what is cosine similarity and why we are using the cosine similarity? So those who haven't watched those videos, please go and watch the series from the beginning. So you will get a complete understanding of what exactly the cosine similarity is. And the third thing that we are going to see is I'm posing a question for you that whether you're agreeing with the cosine similarity assessment of similarity, that means for comparison. Okay, so these three are the topics that we are going to see in this particular notebook. So let us dive. So first thing, so as I will usually tell for you, like whenever you're doing a particular project, first thing is that you have to see what are the required libraries or the packages that you need to install. So these are the particular things that you need to install. First thing is sentence transformer, which is a base package for doing with the transformer thing, which is like a starting point for a bird. And then torch, which is a very useful package for doing this LLM simple task, and the data sets for getting the predefined data sets which are already imported, and then OpenAI package, which is useful for doing all the ChatGPT API related functions and all. Next thing is you have to import this. So from the sklearn package, you have metrics.pairwise. In that particular thing, you're using cosine similarity for comparison. And the next thing is the OpenAI method, which is useful for doing a task with respect to the OpenAI package. Okay. Next, you have to load the ARC dataset. Okay, so ARC dataset is one of the predefined data set that is available. So we can use the data set for doing this particular task. Of course, if you want to explore different question answer related data sets, so these are also some data sets which you can explore. First one is the HelaSwag. And the next one is MMLU, which is called Massive Multitask Language Understanding. So you can use these particular data sets for doing the similar task which I am showing you. The next thing is you have to import the data set. So for that, you're using from datasets import load underscore dataset, and then the dataset name, which is nothing but ARC. And then you're taking a variable and then you're loading the data set with the help of load underscore dataset method by giving the dataset name, okay, with the help of this particular function. Okay, and once you're done with that, you'll be loading your data set here completely, and then you have to create the question answer pairs. I think you have seen this particular thing previously too, so I will just go in a brief. Okay, so in order to create a question and answer pair from the given data set, you have to take an empty list, and then you need to define some size, and then the counter variable for increment for doing the loop. Okay, and then you have to write a simple loop, that is by using the for loop, and you're taking a variable sample in your data set, and you're taking a trying thing, because you can use like usually in the machine learning, like in this particular like scenarios, normally the usual trend that will follow is training set, testing set, etc., right? So so you're taking like data set of train, and then you're taking a question and sample dot get of question, and choices sample dot get of choices, and then you're for the particular question with the different choices, you're just using the dict, which will bind all your labels along with the text, and then again question and answer pair, and then question with question, and then getting some sample answer key, and then you're using prepare dataset dot append and your question answer pair. So if your len of prepared dataset is greater than size, then you're breaking that particular thing. Okay, so that means whenever you are writing a particular dictionary or something, first you have to check whether that is valid or not. So not only this particular thing, any programming language, first like there will be some conditions, right? So basically the simple phenomena that you're writing here is you're taking a question, you're taking an answer, and you're combining that into the particular dictionary, and in that way you are preparing the entire data set. Okay, next you're just seeing whatever you have done, that is whatever the data set that you have prepared has been correctly done or not. Okay, so for that you're doing this particular thing. So from the random import sample, and then you're taking some 5 samples, that means you're just printing the 5 questions that which you have prepared from your data set, and then you're taking some variable, and then you're just giving your sample function the prepared data set as well as this the number of samples that you want to print. Okay, and then for INQL list, and then print of a question of I question and print of F. So you're just printing the question answer. See, you have 5 questions, 1, 2, 3, 4, 5, and with the help of 5 answers. Okay, so the next thing is, as I mentioned, you are comparing 2 different models. So for that, you are using 2 different models. So the 2 different models that we are using here is GPT-4 and GPT 3.5 Turbo. So I'm just taking 2 variables, that is model 1 and model 2, and then giving the model names for initialization, and then I'm using the OpenAI key and your key API key, and then you're just taking a variable, and then you're using OpenAI method, and you're just initializing your API key. Okay, and then you're defining a function that returns an answer for your question. So for that, I'm just having this simple function. So def is a function keyword in Python, and then you're giving some relevant, not relevant, it's like a the appropriate function name for what you're doing the task. So that is get answer from OpenAI, and then you're just giving your model, that is you're passing your model and the questions that which you have prepared. So the response variable is equal to OpenAI QA model, that is what is the thing that you have initialized dot. So this is the simple function, that is method which you are seeing so many videos, that is chat.completions.create, and then you're just giving your message. So this is the syntax, the normal phenomena that you will follow whenever you are doing LLM stuff. So you are giving role, and this is the system, and then the content, and then the role content. Okay, so these are the so if you see the LLM documentation, you can understand what is role, what is content, what is system, everything. Okay, so already I have explained you in our previous videos. So again, I'm telling those who haven't watched it, please go and watch. Okay, so you'll get easy understanding. These are the fundamental things that you have to understand whenever you're doing with LLM. What is role? what exactly the content, what exactly the context that you're setting. Okay, so basically I will tell you in the simple way. Whenever you're preparing something or whenever you're doing something with LLMs, there will be some defined rules that you have to understand whenever you're settings a context for your LLM. So that is the roles, these like those are the roles that we are discussing now. Okay, next, model is equal to model temperature, and there is one more parameter called max tokens that to limit the response of your to limit the tokens for your response. Okay, so that also you can use. Okay, so model is nothing but the model which you have defined, and the temperature is, as I told, the temperature is basically helps for getting the randomness in your output. So if it is close to 0, there will be less randomness, and if it is more, that is, it is in the range of usually 0 to 1. If it is more near to 1, there will be more randomness in your response. The randomness is nothing but relevance. Suppose in some user cases you want the same similar type of responses. Sometimes you want to check vivid responses. So in that time it will be very helpful. And then you're just returning your message. Okay, and then you're using a for loop, and then you're just pairing up with your answers and format of model 1 and model 2 for two different models, and then you're calling your function and then giving your question. So then here you're just printing your answers. So see, the question is George wants to warm his hands quickly by rubbing them. Which skin surface will produce? So answer for dry palms, and then for GPT 3.5 you're getting palms, and GPT 4 you're getting the palms. Okay, so now what you're doing is, so you're just using a BERT model, like you're defining the BERT model, and you're just using that model. So from sentence transformer, import sentence transformer, and then you're using cosine similarity and taking the BERT model, and then you're using this BERT, like running this BERT model first, sentence transformer BERT model, and then you're loading this. Now what you're doing is, in the BERT model, with the help of cosine similarity, you're evaluating your particular two models. So that's why you're creating this function. So calculate underscore cosine similarity of question and answer. You're just encoding your question, you're encoding your answer, and then finding the cosine similarity for your embeddings. So basically this, why we are embedding. So embedding is nothing but converting your text into the numbers. So a model cannot understand the numbers. So that's why you're just encoding. Okay, so transformer is basically encoder and decoder. So I already explained the architecture of transformer even in our the last week, and last week video is about part 3. So there are total 3 parts in question and answer system. So I have clearly explained them, why you are using BERT model, why you are using sentence transformer, why you are using cosine similarity. So please go and watch that video, so so that you can understand this. Okay, so basically you are using the cosine similarity for evaluating the cosine similarities for two different models, so that you can compare. Okay, so now you're just processing your everything with the help of this function. For the two models, you're just calculating the cosine similarity. So you're just using two variables in your prepared data set, and you're just printing the question, your answer, and cosine similarity for your question and answer. And then for model 1 you're doing the same, and for model 2 you're doing the same. So if you observe here, this is the question, this is the answer, and the correct answer, the question similarity is this. And for your 3.5 turbo, you're having 0.82 distance, and for GPT-4 you're having a 0.72. Okay, so like this you have did for all of your questions, and then printed for all of your questions the cosine similarity. So now tell me, I'm posing you the question, so how you can select the best model in these two, whether GPT 3.5 turbo or GPT-4, because here you have observed the cosine similarity distance. For GPT 3.5, for this question you are getting 0.82, and for this question it is 0.72, and similarly for second question 0.55 for GPT 3.5, and for 0.90 for GPT-4. So like that, for every question there is a variation in so cosine similarity for one model and other model. So how you can select the best model? So this is the question that I am posing. So please answer your question, like answer in the comment box, so that we can discuss further more in our next video. I hope you understand this video. Please like, share, and subscribe to my YouTube channel, and also please comment the things that you want from me, like to explain. Thank you so much for watching the video. Thank you.